want to walk you through how we're going to make this concrete. Okay, so our binary search tree is going to store students, right? And so here are our students. If I look inside student, a student has a name and an ID, okay? Now, our binary search tree is actually going to store anything. It's going to be a type T. We're going to use it with students, but we could use it with balls or something like that. Well, how do we know that a type T is going to be able to give us a key value? Okay, in our case, in student, the key value is going to be ID. Well, the reason we know that is because we have something in object called hash code, which is an integer representation of our object. Okay, and so you can implement hash code as long as it returns a number, it's fine. So two objects can have the same number, but it won't be as efficient as if each ID is unique. And so you might be thinking about that, right? About how we talked about hashing before, right? And what that means, what hash code means to have each object return a unique ID. In our case, we are returning a unique ID. We're inserting, we're going to assume that everything we insert has a unique ID, and hopefully there's a check happening before we get to this particular code. If there wasn't, we should put a check in this particular code to make sure that we're not inserting duplicate IDs, because that's one of the things we're going to assume with this binary search tree exercise. So hash code is like the getter for the ID, and it just returns the ID. Okay, the ID being the 700 number of the student. So hash code is just, in this situation, is just a amazing way of saying it's going to return the ID. Okay. Now, what's advantageous about hash code is it's inherited, so it's overridden from object, meaning that even though this is a type T and we don't know what it has, okay, or what's going to be passed in for it, what type's going to be passed in for it, we know that we will always be able to call hash code on it, and it'll give us some value, okay? In the case of we don't implement it, it will, I think, return the value, like an integer value of where the object is located in memory. So not exactly what we want, right? This is much more useful, our implementation here. Okay, so far so good. So now we have to think of, well, we have this inner class BST node. So we have this BST, okay? And inside the BST, we have a BST node reference to the root of the tree. Okay, we have a constructor here that points the root to null, meaning that when we create a binary search tree, it's an empty binary search tree with the root pointing to null. Okay, eventually we're going to insert some data, some type T, and what we're going to have is we're going to have the root pointing to a binary search tree node. In this case, our root let's say we want to insert A, right? Our root is going to point to a binary search tree with A, and its left and right equal to null. Okay, so I want you to think, sorry, I just had a brain dying here. I want you to think, what are going to be the private variables of BST node, right? What are the things in it? So it's going to represent a student, and it's going to be able to be the root no matter what the node is. It's always going to be able to maybe reference two other things, right? A left and a right. So think about what that's going to be. We're going to have a question for that, and then we'll get back to the work of the people.